Good evening. Today I'm going to discuss the topic pressure cell. Let's look what is a pressure cell. A pressure cell is a type of sensor that converts stress or pressure into a measurable or readable electrical unit. The pressure cell is fundamentally used to measure the total stress in various geotechnical construction fields. The vibrating pressure cells are based on vibrating wire technology. Let's look how it works in geotechnical field. The rock or soil formation is completely dependent on the rock or soil type, stress history, shear and normal stress levels, boundary and drainage conditions, and several environmental effects. The precise assessment of stress and changes that occur in foundation, soil, or rock formations is of great importance for safe engineering design. While constructing the large civil engineering projects like tall buildings, dams, underground tunnels, etc., the measurement of stress plays a vital role. There are two categories of stress, and they are: first one is the measurement of total stress at a point within a soil mass or foundation rock or concrete structure. Second one is the measurement of contact stress against the face of a structural element. The vibrating wire pressure cells are much reliable and faster than all other types as they are capable of taking readings electrically as the frequency output is almost immune to external noise. The cable from the pressure sensor is connected to the readout unit or data logger and is protected against any possible damage during construction to give all around reliable data. The applications of pressure cells are: the pressure cells are designed to monitor radial and tangential stresses in short grid tunnel linings, underground excavations, unlined caverns, and foundations. Pressure cells are used to assess the adequacy of the short grid lining. They are used to monitor mine blackfill, to measure the orientation and magnitude of total pressure and stress distribution within dam embankments and the interface of soil and concrete, to determine contact pressure on retaining and diaphragm walls, pipers, and abutments. Let's look the working principle. A pressure sensor converts the stress or applied pressure into measurable electrical output. The pressure can be defined as the applied force per unit area that a fluid exerts on its surroundings. The pressure is given by the equation pressure is equal to force by area. The pressure transducers consist of a sensor with a constant area and respond to the force applied by the fluid pressure. The force applied tends to deflect the diaphragm inside the pressure cell. The deflection of the diaphragm is calculated and converted into readable electrical output by the data loggers or readout units. The pressure cell is used to weigh extremely heavy loads. For example, a length of bar, usually steel, is used as an active element. The weight of the load applies a particular stress to the bar. The amount of strain which results in the bar for different values of applied stress is determined so that the strain may be used as a direct measure of the stress causing it. As stress applied along a particular direction, the steel bar in the pressure cell experiences a compression along that axis and expansion along the x and y axis. As a result, gauge experiences a decrease in resistance, and another gauge experiences an increase in resistance. When these two gauges and gauges on the two remaining sides of the steel are connected to form a bridge circuit, four times the sensitivity of a simple gauge bridge is obtained. This makes the load cell sensitive to very small values of applied stress as well as extremely heavy loads. Now, moving on to the advantages. The first one is conformance. It means to minimize bridging effects. The total pressure cell has a low profile and a modulus similar to that of a typical soil. Fluid in the cell is de-aired to maximum sensitivity. Second one is the pneumatic or vibrating wire. The total pressure cell is available in a pneumatic or vibrating wire version. Third one is the manual or automatic readout. The vibrating wire version can be read manually with a portable indicator or automatically with a data logger. The pneumatic version must be read manually. The total pressure cells are embedded in fill or mounted on structures. The infill cells are often installed in arrays. Each infill cell is placed in a different orientation and occurred with hand compacted fill. On structures, the cell is typically placed into a recess so that its sensitive side is flush with the surface of the structure. The total pressure cells are formed from two circular plates of stainless steel. The edges of the plates are welded together to form a sealed cavity which is full of fluid. Then a pressure transducer is attached to the cell. The cell is installed with its sensitive surface in direct contact with the soil. The total pressure acting on that surface is transmitted to the fluid inside the cell and measured by the pressure transducer. Therefore, pressure transducer pressure cells works on the working principle that the fluid pressure causes the diaphragm to deflect. It also contains a transduction element, and this element converts the deflection caused by the diaphragm into an electrical output signal. And the transducer used is a strain gauge based transducer in the pressure cell. Now, thank you.